Welcome to the Kusto Query Language from Scratch course. This module is working with datasets. I'm Robert Kane, and I'll be your host for this course. Every time you author a query, you return a dataset, even though you might not have realized it. In this module, you'll learn additional methods for working with those datasets, such as joining multiple datasets together, referencing the previous or next row in a dataset, and more. For your reference, here is a list of the keywords we'll be covering in this module. Each keyword will be in a clip of its own for easy reference in the future, should you wish to return and refresh yourself on a specific operator. Out of all the keywords in KQL, let has to be my favorite. That's because it is so incredibly versatile. Here you can see I'm creating a new variable called minCounterValue, and I'm giving it a hard-coded value of 300. Essentially, this is going to wind up being a constant. Underneath that, I have let counterName equals free megabytes to indicate the counter I'm looking for. And then here I have my main query. You'll note at the end of each one of those let statements, I have a semicolon. The semicolon is KQL's indicator that says, hey, even though I've reached the end of this particular statement, my query continues on the next line. Within perf, you can see down here in the where clause, I'm saying where counterName equals counterName and counterValue less than or equal to minCounterValue. The beauty of this is I can easily change those values should I wish to rerun this query. I could come up and change minCounterValue to 200 and weed out some of these results. This is also a good time to remind you of something we mentioned way back in Module 1. That is, KQL is case sensitive. You'll note here that my column name from the perf table, counterName, begins with an uppercase C. The variable I created, counterName, begins with a lowercase c. This is where KQL's case sensitivity comes into play. It allows us to do things like this. So just be careful when you're creating your code that you be on the lookout for any case-sensitive issues. In this example, we made it easy to create constants that we could update, but another good reason might be when we want to reuse a particular variable within our query. In this example, you can see I've done a let compName equals, and then within the query itself, I have where computer equals compName, and then I use that variable again within the this is for extend statement, where I say this data is for computer, and I tack on the computer name. Granted, this example is very simple, but I have seen queries that were many lines long and where a variable such as compName might be reused 7 or 8 times. This makes it very easy to update the variable. It's right there at the top. You would only have to update it once rather than having to change it all throughout the query. Let can also be used to hold calculated values. In this example, I'm doing a very simple calculation. I'm just calculating what 12 hours ago was, but you could do much more complex calculations here. And here's my results. You can see I've got data from 12 hours ago up until now. Another reminder from something we've said a few times in this course, the output of any query is a data set. Even if the query is something as simple as perf, that output is still going to be a data set. Well, you can use let to capture a data set and store it in a variable. Here, of course, I have the let compName equals at the start of this. You've seen that before. We then have let, and then I've got a variable called updateSum, short for update summary. And my query is actually update summary, where computer equals my variable, and then I have the rest of the query. At the end of this, I have the semicolon, which indicates the query will continue on the next line. I then have my second variable that is going to hold a data set. This variable is update, short for update, and it queries the update table. Again, this ends in a semicolon because we're continuing the query. And then we fall down here to a union. Now we'll talk about more on unions just a little later on in this module, but the short version is unions marry together two data sets. And I'll run this and we'll see that yes indeed we are getting data back. Using variables made this union statement incredibly simple to read. As they say on TV, but wait, there's more. You can also use the let statement to create a variable that holds a function. Yes, you can define your own functions in KQL. Here I've got a function I'm going to call date diff in days. I then have it set to equal, and then within the parentheses I have the parameter declaration. The first parameter is going to be named date1. I then have a colon and the data type for this variable, date time. I have a comma, and then I have the next parameter, date2. I have a colon, and then I have date time data type, and then on this one, I have it set equal to, and then I've hard-coded in 2018-0101, and then I had to wrap that in a date time command so that it would be the true date time data type and not be interpreted as a string. Now what this does for me is provides a default value. If the user doesn't pass in date2, it'll use whatever is after the equal sign. On the next line, I have my set of squiggly races, and then in it, I have what I want the function to do. I take date1, subtract date2, take that output and divide it by 1D so that the output will be in days. So after creating the function, I have my semicolon, and then I fall into a print statement that I'm using just to illustrate its use. In a normal situation, I would define this function and use it within a bigger query. So after the print, I call date diff in days. I pass it in now in the date1 position, and I hard-coded a date in here of 2018-05-01, and I have to cast that to a date time data type using toDateTime. So when I run this, it's going to tell me that it's been 22 days since May 1st. Here's a second example where we're not passing in that second parameter. It's going to use the default of 2018-01-01 in this case. And I can execute this and it tells me it's been 142 days since the start of this year. I will mention that I placed the squiggly braces and the function call all on the same line. You could actually use multiple lines if you felt it made it more readable. Hopefully now you see why the let statement is one of my favorites within KQL